In case I haven't had the opportunity to introduce myself to you yet, my name is Justin Solomon, and it's my pleasure to moderate this evening's panel, as well as one this afternoon and this morning. So the theme of our panel for this evening is all about data visualization, in particular understanding urban and electoral data. The basic concepts that we're trying to get at here is that really visualizing and understanding what goes on in cities is insanely critical to understanding a lot of the challenges in addressing gerrymandering. In particular, there's obviously a lot of concentration of particular political beliefs in cities, as well as just a very high population, a very high concentration of people that we have to figure out how to split up. So in order to split these folks fairly, you really have to understand something about the anatomy of a city and how people interact with it. Without further ado, I will introduce our first speaker here, who's Ariel Mdange Pfupfu. So Ariel studied physics at Stanford and got an engineering PhD from Northwestern. For the past 2 years, he's worked at Data Incubator, which is a data science education startup focused on hands-on learning. Besides designing and optimizing data workflows and tackling software engineering projects, he spends time on curriculum development and instruction. Ariel believes in the importance of data science literacy and communication skills both for practitioners and stakeholders, and sees visualization as a big part of that skill set. So with that, I will give the stage to Ariel.
Thanks, Justin. All right, can you guys hear me all right? Cool. So yeah, like Justin said, I'm all about hands-on learning. And what I want to talk to you today about is how to actually build tools using open source technologies that are out there free for anybody to use. You might have noticed from my bio is that I've constantly gone from more theoretical to more applied. So I really like just the part where you actually get to build stuff. And what I want to show you in a bunch of code, which you don't really have to pay too much attention to, is how easy it is to use a language like Python to make a visualization tool that lets you visualize location-based data. So why Python and why Folium? Folium is the name of a package for Python, which we're going to be using. Python is really all about plugging into a whole bunch of different technologies. I like to talk about it as the minivan of programming languages. It's not the sportiest and it's not the most compact, but you can throw whatever you want into Python and it will get you to where you're going. So what we're going to go through is a really quick demo that I threw together over the past 2 days that shows how we can throw in mapping from Leaflet, API calls to open transit APIs in Washington, DC, and web hosting with Flask and Heroku to actually make a little, to do a couple different things. To do a bus tracker, so we're going to look at some live bus locations. We're going to make some choropleths based on census data, and we're going to lastly look at some walk score data from the walk score API. So again, the takeaway here is not really the details of this. I'm going to push all of this up to GitHub. I'm sure the link will be made available to you somehow. And all this stuff is on the internet, so you can look at it there. But I'm going to show you how all these pieces kind of fit together to make a tool that you might end up actually giving to somebody to use. So, blah, 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 lots of motivational stuff up here. So let's get to the fun part. A lot of what we want to do in mapping is geocoding. So there is a Python package for that. It's called Geocoder. And we could call like a geocoding API, but this is a perfectly fine way to do it as well. And you can see that I can plug in a location, like for example, DuPont Circle, neighborhood in DC. And I can actually just say, hey, Geocoder, go use the Google geocoding service for that string and give me back this location object. That location object has a latitude and longitude, also has a Geo JSON, has a whole bunch of stuff associated with it. So once I have that location object, I can go to Folium, my mapper, and say, hey, Folium, make a map with the location at that latitude and longitude. And so just with a few lines of code, I can get a map that looks like this, right? So this is an interactable map. I can scroll it around, and if my internet connection holds, different parts of the city will load. I can zoom in, and because this is OpenStreetMap data, you can see it's very rich in terms of what's actually there. And yeah, this is DuPont Circle. So this is just one layer that I can build on. So in the interest of time, I'm not going to spend too much time on any one of these things, but this is one of those things I wanted to point out in terms of how we plug in now maybe some outside data. So what I did is I went to the WMATA website. WMATA is the Washington Metropolitan Area Transit Authority, and they have an API. Justin talked about urban structure. Well, cities are at the forefront of making their data publicly available in rigorous and robust ways. And Washington, D.C., New York, Chicago, San Francisco all come to mind, where you can just go and get huge quantities of variety of data very, very easily. What an API means is I can just structure essentially what is an HTTP request to this website at wmata.com, and I can give it some info like I want buses around this latitude and longitude and such radius. And I can provide it this input, and the output it gives me looks something like this, some JSON object with a whole bunch of buses. And you'll see if you dig inside this JSON object, well, here's a bus at this latitude and longitude. It's going kind of west on Route 96. And if I run this code again, it will get some new data. I mean, we can do that right now, because this is live code cell. And live demos are always fun. So what happens is that I can then go through and use a for loop or something and take all these bus markers and put them on the map. So now I have locations of where buses are on this map. There is something very powerful about doing this. You can easily get carried away and just keep calling it more and more live data. A lot of what we want to do when we actually build these tools is be very careful about the load that we're putting on these services. So you'll notice here that I am doing what's called checkpointing, and I'm actually not going to call the API again if I think I already have that data. That's what this refresh equals false means. So if I change this refresh equal to true, then it's going to actually query the API for some new data, and we can plot that and see that now the buses are in different locations now because I updated it to right now. So this is a very simple idea, but it's very powerful, and again, probably something that you can build on. You can add more information on top of this. So some of the other things that Folium can do, Folium is a wrapper around the leaflet.js library. It's a JavaScript mapping library you're probably familiar with. What you may not know is that Leaflet works really well with Geo JSON. Geo JSON is very similar to the shapefiles you may have been hearing about. A lot of GIS data comes as a shapefile, which is basically something which is kind of like this, where you have a whole bunch of coordinates here which kind of delineate a polygon, and then you have some data associated with that shape. GeoJSON is just another form for that. So there are tools to convert back and forth between these as well. So if you have a shapefile you'd like to use with this code, by all means, use an online tool to turn that shapefile into a GeoJSON, plug it in here, you'll see it on the map. So besides the shape, you can see that this particular GeoJSON I'm working with has fields like area, it has fields like perimeter, POP90, which is, I believe, the 1990 census population numbers, poverty group, poverty rate, et cetera. And because we have shape data correlated with values, now we can start doing whatever data analysis you want. Here I'm just going to use Python's Pandas package, which is basically a data frame, rows and columns, to go through and do, make some derived columns based on maybe density, because I think population by itself is not that relevant, but the density is more interesting. And then whatever values I come up with, I can set up a color map to kind of represent the scale of how that value changes. And again, just skimming through this, you can take all of that, that value data that you have and plug it onto this map. So that looks something like this. you can see that I can tick on or off these layers. So I can tick on poverty rate, I can tick on population. I've plotted population in blue, poverty rate kind of in red, purple, so that you can kind of see where they overlap. So now you can like see at a glance, oh, here's some areas that are kind of purplish. That means they have high population and high poverty rate. Or here's some areas that are just dark blue, high population, but poverty rate's pretty low. So you can do a lot of analysis very quickly with this kind of technique. And obviously I could go further. I could take the buses and overlay that on here. I could do all sorts of things. What I thought might be kind of interesting was to look at walk score. And I'm not sure how much time I have left, but cool. So walk score is just this kind of proprietary measure of how walkable a location is. One thing that I thought about as I was putting together this bus demo was what's between bus stops? I think about maybe we put bus stops in populated places which are probably pretty walkable, but what's between those bus stops? Do the buses go over like a desert, or are they just going among lots of populated areas? And it turns out that WMATA has data on their API that give you basically the entire shape of a bus route and not just the stops. So that's what I'm doing in this next part. I'm taking the entire shape of a bus route, again, calling another API, now the walk score API, to get a walk score for every point along that bus route. And again, using caching, because I really don't want to piss off the walk score people. You can see I'm very careful about branding here, so don't take away my API key. What I can do is then plug in a route, again, an input, and get some data out. So here's a walk score, bike score, transit score. Their transit scores aren't very good. And so what that might show me is something like this, where, okay, well, here's a particular bus route in DC. I can tick, again, these layers on or off. I plotted on a different background map this time, because maybe terrain is kind of more interesting when you're looking between bus stops. And so this is Rock Creek Park. Not a lot of people living in Rock Creek Park, not a lot of shops in Rock Creek Park, so the walk scores are lower. And you can kind of see that here. And obviously I could do this with lots of different routes and stuff like that. So again, I just wanted to show you kind of what's possible here. It's not very complex what I'm doing. It's just a matter of taking these disparate data sources and disparate technologies and plugging them into each other. That's the trick. One last thing I'll show, just as the cherry on top, is how easy it is to turn code like this into a web application that you can publish for anybody to use. The beauty about Python is that I can write my web application in the same language I did my data analysis in. So here's my web application. It's really hacked together. It's not super long, but this is basically, if you know a little bit of HTML, there's a template which has a form, and the elements from that form are passed into this application. I ask for a location, I ask for a radius, and I take that information and I set up my call to the WMATA API here. I draw my map using Folium, and then I render that HTML. So this is live right now on this site because of Heroku, which is a free web hosting service for kind of small, not production scale, but small apps. And this just works, right? I can type in, Logan Circle, radius of 1200. Obviously, I'm going to use cached data if I can to spare the API, but I could always turn that off. And what this is doing is behind the scenes doing all that stuff which I just showed you. And then it will generate this map that you can play with. So as this thinks about it, I'll stop there and ask if there's any questions, comments, snide remarks.
All right, let's thank our speaker. All right, so we're going to have a little bit of a ballet kind of thing here. So we're going to switch speakers up here. I'd like to remind everybody that they can ask us questions by going to tinyurl.com/askjerry, and I believe we'll see them there. Maybe while we're switching speakers, I'll go ahead and ask one question to start discussion, and then we'll have about 20 minutes to talk with the whole panel at the end, by the way. I probably should have laid all this out at the beginning. Right, so do you have any ideas for how to use these kinds of data to visualize or conceptualize a community of interest?
Yeah, well, it's all about finding either direct variables or proxy variables that you can use to kind of get at that idea, right? So if you're talking about a community of interest like, say, lawyers, that may not be very obvious or very easy to get on like census data, but you might be able to use OpenStreetMap data to find businesses that match certain things like bar, or figure out some way of getting at where lawyers might be. And then you might be able to, with some degree of certainty, say, I think that this area is a cluster of where lawyers are. Or obviously lawyers is not a very relevant example, because you don't care about that community of interest, but, or I shouldn't say we don't care, but they can protect themselves.
I'm not sure that protecting the voting rights of lawyers is our main priority.
They can protect themselves. But yeah, so a lot of what data science is thinking about what are the right features to use, what features can we use as indicators for things that we really care about.
Okay, excellent.